Hello, welcome to Knowledge of Physics. In this video, I will show you how to find out derivatives of the given functions from first principle. So, these are the functions which can be asked in examinations to find out the derivatives from first principle. So, stay with us till the end of this video so that you will learn something new and very interesting. So let's get started. The given functions are x to power x, a to power x, 2 to power x to power x square, x to power sin x, and x to power cos x. Okay, and the function is in the form of x to power x, variable to the power variable, and power variable to the base constant base. For example, 2 to power x and so on. So let's get it started. To find out the derivative of these functions, first of all you have to remember some relations. For example, to find derivative of function of type this one, the derivative of for example, the derivative of function x to power x with respect to x is given by x to power x times d by dx x dot log x, and x dot log x is in the form of product of two function of x. So you can apply here a product rule of finding derivative, and you can find out the derivative of x to power x with respect to x. And similarly, and for the function a to power x, here a is a constant and variable x is given as the exponent or power of the constant term a, and its derivative with respect to x is equal to a to power x d by dx x times log a. Here d by dx x times log a, here log a is constant, so you can find out the derivative of x with respect to x. And product rule is given as if u and b are two functions of x, then derivative of u v with respect to x is given by b times du by dx plus u times dv by dx. We can apply this product rule to find the derivative of this d by dx x dot log x. And similarly, you can find here, if you find the derivative of function x power sin x, then derivative of x power sin x with respect to x is equal to x power sin x times d by dx, here sin x times log x. In this way you can apply the same rule to find out the derivative of x to cos x. But in this video we have to find out the derivative of this function by using first principle. So let's get it started. First of all, the function is x to power x. Okay, suppose in number one there is x to power x. So first, finding the derivative of this function, let's consider y is equal to x to power x, and let this be equation 1. Taking log on both sides, to find the derivative of such function we have to take log on both sides, so that we get log y is equal to log of x power x, and this can be written as x log x. This is the property of logarithmic function. Then you get log y is equal to x times log x, which is equation 2. To find the derivative of the given function from first principle, we have to suppose del x and del y be small increments in x and y respectively. Then equation 2 in the form of del x and del y can be written as log of y plus del y is equal to x plus del x times log x plus del x. Let this be equation 2. This is equation 3 actually. Here is equation 2 and this is equation 3. So please make correction here. And subtract equation 2 from equation 3, we get log of y plus del y is log of y plus del y minus log y is equal to x plus del x times log of x plus del x minus x log x. And after opening the bracket, this x plus del x bracket with log x plus del x, we get this line. And here on left hand side you can apply the property of logarithmic function, that is log a minus log b is equal to log of a divided by b. So applying the same property here, log of y plus del y by y, we obtain this term on left hand side, and on right hand side we have to open this bracket, so you get this type of relation. And here you need to separate y in the denominator to y plus del y, and we get log of 1 plus del y by y is equal to, and from this x log x and this x log x plus del x, I took common here x, and inside the bracket log x plus del x minus log x is there, and plus this term is as it is. And the here also we have to apply the logarithmic properties of logarithmic function. Log a minus log b is equal to log of a divided by b, so it is log x times log of x plus del x divided by x plus, and the second term is as it is, and you get log of 1 plus del y by y is equal to x times log of 1 plus del x by x plus del x log x plus del x. Now we have to divide both sides by del x, then we get in next line we get log of 1 plus del y by y divided by del x is equal to x times log of 1 plus del x by x plus del x log x plus del x whole divided by del x, and I separate the del x to first term and second term here, so we get x of x times log of x plus del x by x whole divided by del x plus this del x cancel out, so in the second term we get log of x plus del x only. Now taking the limit on both sides as del x tends to 0. In first principle of derivative means to use the concept of limit in finding the derivative of the function. So taking the limit as del x tends to 0, we get limit del x tends to 0 log of 1 plus del y by y by del x is equal to limit del x tends to 0. Inside the bracket there is x times log of 1 plus del x by x divided by del x plus log of x plus del x, and on left hand side we have to modify here. Okay, for example, inside the log function there is del y by y, so we have to write this term in terms of limit del y tends to 0. So I here the given factor is limit del y tends to 0 log of 1 plus del y by y divided by del y multiplied by limit del x tends to 0 del y by del x is equal to x times limit del x tends to 0 limit 1 plus del x by x whole divided by del x plus, and the second term is as it is after using the limit del x tends to 0. Okay, on right hand side I can write here 1 plus 1 divided by y here, okay, outside the limit, because this term is independent of del y. Okay, so 1 by y, and after that dy by dx is there, and this term is written inside the bracket limit del y by y tends to 0 log of here del y by y tends to 0 is missing, so you can add it log of 1 plus del y by y whole divided by del y by y, and this term is in the form of a standard form limit the x tends to 0 log of 1 plus x divided by x, and it gives you the result 1, and we can use 1 here as well. And on right hand side the first term is x is taken out from the limit, and 1 by x is also taken out, and inside the bracket there is a limit del x by x tends to 0 log of 1 plus del x by x divided by del x by x, and plus in second term you use del x equal to 0, and you are left with log of x. In next step, so 1 by y is there and dy by dx is there, this term is 1, so there is no need to write 1 here, and x by x is here, and the second term is log x, this whole term is 1 here. Okay, so dy by dx is equal to, after taking this y on right hand side, we get dy by dx is equal to y plus y times 1 plus log x, and value of y is x to power x. After substituting the value of y x to power x, we get the derivative of x to power x with respect to x is equal to x to power x times 1 plus log x. So derivative of x to power x with respect to x is given as x to power x times 1 plus log x. This is equation 3, and this equation represents the derivative of x to power x with respect to x. So you can see here derivative of x to power x is equal to x to power x itself times the term after taking the derivative of the or applying the product rule, okay, in the remaining terms. So this term represents d by dx x dot log x, okay. So this is the derivative of the function x to power x. Now in same video I want to show you to find out the derivative of a to power x. In previous problem we found the derivative of x to power x, but in this video in this step you see a to power x. Here the base is constant, any constant number. In previous one base is x, so little bit different, but this one is easier from the previous one, okay. So to find the derivative of this function we have to suppose y is equal to a to power x, okay. Y is equal to a to power x. Let this be equation 1. Take log on both sides, we get log y is equal to log of ax, and ax comes out of the log, so x times log a. So this is equation 2. Now we have to consider del x and del y being small increments in x and y respectively. Then we can write equation 2 in the terms of y plus del y and x plus del x as log of y plus del y is equal to x plus del x times log a. So there is no variable inside log, so there is log a only. This is equation 3. Now subtract equation 2 from equation 3. We get log of y plus del y minus log y is equal to x plus del x log a minus x log a. So after opening this bracket we get, and using the properties of log function here, we have log of y plus del y by y is equal to x times log a plus del x times log a minus x log a, and x log a cancel out. So we have log of 1 plus del y by y is equal to log del x times log a. Now we have to divide this equation by dy. Okay, divide both sides by del x. So after dividing it we get log of 1 plus del y by y divided by del x is equal to del x times log a divided by del x. Del x cancel out, so we are left with log a on right hand side. Now taking limit as del x tends to 0 on both sides, we get limit del x tends to 0 log of 1 plus del y by y by del x is equal to limit del x tends to 0 log a. And after arranging this the terms on left hand side as limit del y tends to 0 log of y plus del y by y divided by del y times limit del x tends to 0 del y by del x is equal to log of a limit del x tends to 0 1. Actually this log a is independent of del x, so I can take it out from the limit. So inside the limit there is only 1, okay, and derivative of limit value of limit 1 is also 1. So on right hand side there is log a only, but on the left hand side we have to arrange here. So inside the log function there is log of 1 plus del y by y, so we have to make it make limit del y tends to 0 as limit del y by y tends to 0. So I made it the same, and limit 1 plus del y by y is there, log of 1 plus del y is there, and on denominator we have to arrange del y by y times y is y and into, and this term is limit del x tends to 0 del y by del x is nothing but dy by dx, which is the derivative of y with respect to x. So after taking 1 by y out of the limit we have 1 into 1 by y into dy by dx is equal to log a. So we have to find out the value of dy by dx. So dy by dx is equal to y times log a, and we can substitute the value of y. So y is ax, so d by dx ax is equal to ax times log a. So you can find see there the derivative of ax with respect to x is equal to a to power x times log a. This is the derivative of ax with respect to x. In this way you can find out the derivative of ax as well. Similarly you can apply this method to find out the derivative of 2 to power x, 2 to power 3 to power x, 5 to power x, and so on. In the similar pattern you can find out the derivative. Now let's move on to another function. This is x to power x squared. This is a little bit complex one. So to find out the derivative of this function, let's consider y is equal to x to power x square and take log on both sides. We get log y is equal to x square times log x. Let this be equation 1. Del x is a small increment in x and del y is a small increment in y. And then we can write equation 1 in terms of del x and del y as log of y plus del y is equal to x plus del x whole square times log of x plus del x. Open the bracket, x plus del x whole square in the form of a plus b whole square is equal to a square plus 2ab plus b square. So after opening this, as we get x square plus 2 del x dot x plus del x whole square times log of x plus del x. This is equation 2. Subtract equation 1 from 2. We get on left hand side there is log of y plus del y minus log y, and on right hand side x square plus 2x del x plus del x square times log of x plus del x minus x square log x square. Now you have to open this bracket with log of x plus del x. Okay, and on left hand side there is log of y plus del y by y. In another step there is log of 1 plus del y by y is equal to, now you have to arrange the terms. For example, x square log x plus del x is there, and you have to arrange term with this minus x square log x. So log x square is taken common here, and there is log of x plus del x minus log x is inside the bracket, and plus 2x del x log x plus del x is as it is, and also del x square times log of x plus del x is also there. So x square is there in another step, and log of x plus del x divided by x is there, and remaining terms are as it is. Okay, and inside the log function here we can write is log of 1 plus del x by x here. Okay, now in next step we have to divide the terms on both sides by del x here. So after dividing it, we get log of 1 plus del y by y divided by del x is equal to x square times log of 1 plus del x by x whole square del x plus 2 del x, okay, 2x times del x log x plus del x divided by del x plus del x square log of x plus del x divided by del x. So this del x, this del x cancel out, and on left side we have to, on right hand side we have x square log of 1 plus del x by x whole divided by del x plus 2x log of x plus del x times log of x plus del x here. Now we have to take limit on both sides at the del x tends to 0. After taking the limit, we can write limit del x tends to 0 log of 1 plus del y by y whole divided by del x is equal to limit del x tends to 0 x square log of 1 plus del x by x whole divided by del x plus limit del x tends to 0 2x log x plus del x is there, plus limit del x tends to 0 del x times log of x plus del x. On left hand side we have to arrange this term in this way: limit del y tends to 0 log of 1 plus del y by y whole divided by del y, because we have to write here limit del y tends to 0 because there is a del y inside log function. That's why we have to arrange in this way, multiplied by limit del x tends to 0 del y by del x. Okay, here del y by del x, not dy by dx. Here must be del y by del x. Okay, is equal to, on right hand side there is x square is taken out from the limit, and limit del x tends to 0 log of 1 plus del x by x whole divided by del x is there, and plus in the second term we have to use del x equal to 0. So after using del x equal to 0 we get this term, and on third term there del x tends to 0, you can write del x is 0 here, and inside the log function you can also use del x is 0, so you get this term. On right hand side there is a limit del y by y tends to 0 log of 1 plus del y by y divided by del y by y times y. Here you have to arrange this term as this, because we have to apply standard form here, and this limit del x tends to 0 del y by del x. This is not dy by dx, this is del x by del y, del y by del x. Okay, and this term can be written as dy by dx is equal to, on right hand side there is x square limit del x by x tends to 0 log of 1 plus del x by x whole divided by del x by x times x plus 2x log x plus 0. This third term becomes 0 here, and on left hand side there is 1 by y, and this term is used as 1, and dy by dx is there is equal to, here x square is there, and here 1 by x plus 2x plus log x is there, and this is what you can write is x. Okay, this x and one of this x cancel out, though there is x only, plus 2x times log x, and on next line dy by dx is equal to y times x plus 2x log x. Now resubstituting the value of y is nothing but x to power x square, so d by dx x to power x square is equal to x to power x square times x 1 plus log x square. This 2 is taken as the power of x square inside the log function. So derivative of x to power x square with respect to x is given by, you can write this is x to power x square and there is x, so you can write it x to power x square plus 1 times 1 plus log x square. This is the derivative of x to power x square with respect to x from first principle. Okay, this term can be written as this one. So if you use the direct rule of derivative, then you can get the same result. Okay, so this is in this way you can find out the derivative of x to power x square from first principle. Similarly, we have another one's problem here in number 5. We have to find out the derivative of x to power sin x. So to find the derivative of this function, we have to consider first y is equal to x to power sin x. Let this be equation 1. In the similar pattern, we have to take log on both sides. After taking log on both sides, log y is equal to log of x sin x, and using the property of log function, we can write log y is equal to sin x times log x. Let this be equation 2. In the similar pattern, we have to consider now del x and del y are the small increments in x and y respectively. This means change in x causes change in y, and writing equation 2 in terms of del x and del y, we get log of y plus del y is equal to sin of x plus del x times log of x plus del x. Let this be equation 3. Now subtract this equation from this equation 3. We get log of y plus del y minus log y is equal to sin of x plus del x times log of x plus del x minus sin x log x. And on right and left hand side, you can use the property of log a minus log b is equal to log of a divided by b here. So this is log of y plus del y by y here, and is equal to sin of x plus del x log of x plus del x minus sin x log x. So right hand side is written as it is. Okay, and on left hand side you can write is log of 1 plus del y by y is equal to sin of x plus del x log of x plus del x minus sin x cos log x. Now divide on both sides with by del x here. After dividing, we get log of 1 plus del y by y whole divided by del x is equal to sin of x plus del x log of x plus del x minus x sin x log x whole divided by del x. And taking limit on both sides as limit del x tends to 0, we get limit del x tends to 0 log of y plus del y by y whole divided by del x is equal to limit del x tends to 0 sin of x plus del x log of x plus del x minus sin x log x whole divided by del x. Okay, and this right hand side term is written as t here. This is represented as t, and on left hand side there is, we have to arrange this factor as this one. So limit del y tends to 0 log of y 1 plus del y by y divided by y del y is equal times log of limit del x tends to 0 del y by del x is equal to t. The right hand term is given written as t here. Okay, further arranging on left hand side, we get limit del y by y tends to 0 log of 1 plus del y by y whole divided by del y by y times y times dy by dx is equal to t here again. So okay, 1 by y comes out of the limit, and the limit del y by y tends to 0 log of 1 plus del y by y whole divided by del y by y multiplied by dy by dx. This dy by dx is there, and it equal to t here. Now this term, all this the terms inside the bracket is equal to 1, and dy by 1 by y is there, dx by dy by dx is there, and equal to t. So we have to find out the value of dy by dx. So dy by dx on left hand side is equal to y times t. Let this be equation 4. Now we have to find out the value of t. and we have to replace the value of y so that we can get the derivative of given function x to power sin x with respect to x. Now from equation 4 what we have is t is equal to limit del x tends to 0 sine of x plus del x log of x plus del x minus sin x log x whole divided by del x. And now substitute to solve this problem. We have to substitute here some values. For example, substitute sin x is equal to u, so that sin x plus del x is equal to u plus k. And also here this is sin x u, this is sin x plus del x u plus k. And also suppose log x is b and log of x plus del x is b plus k prime, so that you get from this one k is equal to sin x plus del x minus u. So u is nothing but sin x, so that you get k is equal to sin of x plus del x minus sin x. And here you can use the relation sin c minus sin d is equal to 2 times sin c minus d divided by 2 times cos c plus d divided by 2. So using the same relation here, we have k is equal to 2 times sine of x plus del x minus x whole divided by 2 dot cos of x plus del x plus x whole divided by 2. And here x cancel out, we are left with 2 times sine of del x by 2 dot and x plus x 2x, so cos of 2x plus del x divided by 2 is there. So k is equal to this one. And also k prime is from here k prime is log of x plus del x minus b, and v is nothing but log x. So we can write k prime is equal to log of x plus del x minus log x. And using the property of log function, we can write and log of 1 plus del x by x is nothing but k prime. And also as del x tends to 0 from here, as del x tends to 0, k tends to 0, because if you put del x 0 here, sin x minus sin x is there, and sin x is equal to 0. So k also tends to 0 here. Same is written here, and k prime also tends to 0 similarly. Okay. And now using all these values in equation 5, we get t is equal to limit del x tends to 0. And you know here in equation 5, sin x plus del x means u plus k, and log of x plus del x mean b plus k prime. So same thing is written here. See, t is equal to limit del x tends to 0 u plus k u plus b plus k prime minus uv whole divided by del x is there. And after opening the bracket, you can write limit del x tends to 0. This is uv plus uk prime plus kv or vk plus kk prime minus uv, and uv we cancel out here. So we are left with t is equal to limit del x tends to 0 uk prime plus uk prime plus vk plus kk prime, and kk is taken as common here, and inside the bracket there is b plus k prime whole divided by del x. Okay. In next line we can write limit del x tends to 0. Here thus del x is separated to two terms. Limit del x tends to 0 uk prime divided by del x plus limit del x tends to 0 k times bk prime divided by del x. And u is sin x, k prime means log of 1 plus del x by x, and there is del x, and plus limit del x tends to 0, k means 2 times sin del x by 2 cos of 2x plus del x by 2, and b plus k prime means this is a log of x plus del x whole divided by del x is there. And sin x is equal to, this sin x is independent of del x, so it is taken out from the limit, and inside the and there is a limit del x divided by x tends to 0 log of 1 plus del x by x into x plus, and here cos of 2x plus del x by 2 is also taken out from the limit, and log of x plus del x is also taken out by using del x tends to 0. And limit del x divided by 2 tends to 0, sin of del x by 2 whole divided by del x by 2 is there, and here sin x is there, and 1 by x is taken out from the limit, and that this is in the standard form, plus cos x is there, log x is there, and this term equals 1, and also this factor also equal to 1. So we are left with t is equal to sin x multiplied by 1 by x plus cos x log x. So t is equal to nothing but t is equal to 1 by x times sin x plus cos x log x. This is equation 6. Now use equation 6 in equation 4. Here equation 4 means equation 4 means this is equation 5 where t is defined, and equation 4 means this. We have to write the value of t here. So using 6 in 4, we get dy by dx is equal to y times this is t, and t is 1 sin x by x plus cos x log x. And let's rewrite the value of y here, x to power sin x and x to power sin x. So derivative of x to power sin x with respect to x is equal to x to power sin x times 1 sin x divided by x plus cos x log x. This is the derivative of the function x to power sin x with respect to x. In the similar pattern, you can also find out the derivative of x to power cos x from first principle, 3 to power x from first principle, x to power 2x from first principle. Try this one and drop your answer in comment section. Okay. So this is the video about finding the derivative of all these functions. These are the complex functions, and they can be asked in the examination. So thank you for watching, and try this and find out the derivative of x cos x and 3 to power x and x to power 2x also, and drop the answer in the comment section.